Okay, I'm going to go over partial fractions when you've got a repeated linear bracket on the denominator. I want to explain why the form is a little bit different, which is what I'll do first of all in blue pen. And then as long as you know the form, you don't have to understand this bit, but as ever, I think it's good to show you. So if you have a repeated linear bracket underneath, so say I have something like x minus 3 squared. I am making this up off the top of my head. Might be obvious, I don't know. And then if I want this to be a proper fraction, so we're still thinking partial fractions, I want it to be a proper fraction. The top could be linear at most, because I've got a quadratic underneath. So if I just put a linear function on top, so say 3x plus 5. You could try this yourself if you want. Then, if you look what happens, I want to sort of split this into two fractions. So I'm going to replace this x with x minus 3, so that the top becomes 3 lots of x minus 3. So the top here now I have 3x minus 9, if I multiply that out. But the right hand side is to equal the left hand side, so I need to add 14 on so that the top is equal to 3x plus 5. And then I can now write this as 3x minus 3 over x minus 3 squared plus 14 over x minus 3 squared. If I divide top and bottom of this one by x minus 3, I get 3 over x minus 3 plus 14 over x minus 3 squared. So what this means is that the partial fraction form for your repeated linear fraction is going to be, so say you have, I don't know if it's with letters or not, but you're going to have a number over x minus 3 plus a number over x minus 3 squared, because you can always go through this process and cancel off at this stage. So I'll go over an example now.